Okay, so looking at the second day of slope and rate of change, you have a assessment and quiz tomorrow, just so you know, so be sure you're getting ready for those. Yesterday we looked at methods used to identify slope from a graph, an equation, and from 2 points. Today what we're going to do is look at methods to apply our understanding to slope of slope to real life equations. One thing they're going to ask you to do is identify M and B, which is your slope and your y-intercept in a word problem. The easiest of these applications is to convert a word problem into a slope-intercept problem. We've already had experience with this, as when you did your application problems, you saw application problems with the words per and each. Hopefully after you've done enough of that, you've noticed that those words actually indicate that we need a variable, because whenever you have something going on over and over and over again or not happening at all, you don't know that the value is, so therefore that makes it a variable type of number or value. For example, if someone is paying $4 per day, if they don't do any days at all, they owe nothing. If they do 1 day, they owe 4. If they do 2 days, they owe 8, and so on. So it changes, and so we would represent it something like 4x. Or, and again, notice that the word here is $4 per day. If 7 people were leaving each hour, again, if after 0 hours no one left, after 1 hour 7 people left. If 7 people are leaving each hour, then after 2 hours 14 people left. After 3 hours 21 people left. And again, the key word here is each, and so we would represent it something like negative 7x. Notice though how the sign indicates the direction of the rate of change. So you are paying $4 per day, so that represents how much you're paying. But if 7 people were leaving each hour, then you need to probably have a minus 7x, because the number of people are going to go down. Other than that, let's look at an example of what we're talking about here, so we can get ready for that assessment tomorrow. It says Terry deposits $800 into his cable account. Each month $9 is deducted from his account. Identify the slope and y-intercept of this equation. Your slope, again, is easily identified. First off, he deposits $800 into his cable account. If you read that statement, there is no each, no per, plus it's just a one-time thing of putting $800 in. So in all honesty, remember your y-intercept is your starting point, but we'll talk about that in just a second. But this sentence does say each month $9 is deducted. So therefore what that means is, here's your each, because again, every month this change is happening. But the thing is, $90 is being deducted, which means that my slope should be a negative 90. So again, read carefully when you do that, because that's pretty much what's going to happen. Your y-intercept, again, is your starting point, and since you deposited $800 into an account, that would be the number that you're using there. So your slope is negative 90. 800 is your y-intercept. If you were going to make an equation for that, it would be negative 90x plus 800, if you remember that y equals mx plus b from yesterday. Another thing you're going to be asked to do is use slope to approximate. So once we understand how to identify slope, we have to actually learn what it means. A rate of change represents a consistent amount by which a value is shifting. If we know what the rate of change is, if we know that the rate of change, for example, is increasing by 6, then we should understand that the numbers in the problem will more than likely shift something like this. It will go from 1 to 7 to 13 to 19, or it could go from 4 to 10 to 16 to 22, or it could go from 100 to 106 to 112 to 118. What is the same thing about, or what is similar about all these patterns, is that all these patterns are increasing by 6. Now, we do not know what the original amount is, but that doesn't really matter. All we knew about this pattern was that the rate of change is increasing by 6. So again, as it says, notice that they all started somewhere random. That would be your y-intercept. Remember, that's your starting point. But they all increased by 6. This is because we knew, again, that our rate of change was constant. So look at an example, a problem that applies the rate of change to approximation. This here says there are 900 people in attendance before a concert starts. It says each minute 45 more people show up. If this pattern remains consistent, how many more people will show up in the next 5 hours? Here's the thing. It's not asking us how many people are going to be there. It's simply asking how many more people will show up in the next 5 hours. Well, if the rate of change if the rate of change is that each minute 45 more people show up, then what that means is that you can say that 45 people are going to show up every hour. I'm sorry, next 5 minutes. So if every minute 45 more people show up, in the next 5 minutes, that 45 should occur 5 times. So all we have to do is 5 times 45, and that should give us our answer that we are looking for, which is 225. Again, what happens is after 1 minute, you have 45 people show up. After 2 minutes, there should be 90 people. After 3 minutes, there should be 135 people. After 4 minutes, there would be 180, I think. And then after 5, you have your 225. So again, that is your rate of change. It is adding 45, adding 45, adding 45. But instead of doing that, if you know it's 5 minutes and 45 people show up every minute, then you can just multiply those two numbers and go from there. The last thing you're going to be asked to do is identify the direction of the slope. Some problems give you a scenario and simply ask you to identify the rate of change or whether it's positive or negative. So look at these following situations here before we get ready to wrap it up. It says a person gets 15 points for bringing one guest and they get 10 points for bringing 2 guests. First off, they want to know, is it a positive relationship? The easiest way to do that is to look at the relationship base, which is 1 guest versus 2 guests. So 1 guest leads to 15 points, 2 guests leads to 10 points. So notice as your independent variable goes up, your dependent variable goes down, which means that this is a negative relationship because again your 1 went to a 2 but your 15 went to a 10. So again, this went up. You can actually use an ordered pair if you want. As your values increased for your independent value, your dependent value decreased, which means it is negative because it's what causes it to go down. Alright, they want the rate of change. Notice how we had 2 points. 1 guest is 15 points, 2 guests is 10 points. So what I could do is go back to my table. 1 guest is 15, 2 guests is 10, and then I could do my subtraction. 10 minus 15 is negative 5, 2 minus 1 is 1. Negative 5 divided by 1 is negative 5, or however else you work that problem out. It should be easy enough to do. If you use the y2 minus y1, if you actually do anything else, it should work for you. One more example, a team earns 35 points for getting 1 question correct, and they receive 43 points for getting 3 questions correct. First they want to know, is it a positive or negative relationship? Again, 1 question leads to 35 points, so I would put 1 leads to 35, or the ordered pair 1 comma 35, and then 3 points leads to 43, and so I could put 3 comma 43. Again, notice as this goes up, that also goes up. That makes it positive in terms of relationship. And they want to know the rate of change, so that means that what we do is put our points down and see what happens. Excuse me. And so again, based off of what we do here, 43 minus 35 is 8. Is it? Got to make sure. It's early. It is. And then 3 minus 1 is 2. And again, we always take our y value minus our x value, so 8 over 2 is 4. And so our rate of change would be 4. Overall, really, this is all you need to be ready for. You already saw the information yesterday. So again, you're going to have an assessment over the past 2 days. Tomorrow you're also going to have a small quiz over material that we've seen in our homework assignments. Again, as long as you've been keeping up with your homework, there's really nothing to worry about. But if you have not, then honestly there's really nothing you can do. But try to start keeping up, and as I said, start fixing your habits, because you're going to hurt yourself if you think that this 5-weight class is going to be something you can just play games in and still succeed. So again, easy enough. You could drop to 4-weight if you need to, and it goes at a slower pace and you don't have the same expectation. But again, if you are a 5-weight student, you need to make sure you push yourself. I have seen, based off of our new books, a lot of 5-weight students with the expectation move to geometry and do okay, and then move to algebra 2, and they have major issues because they don't have the proper habits. So again, make sure your habits are right, make sure you're actually taking the information seriously. And again, if you don't want to take the information seriously, then you should probably consider dropping, especially if you've been struggling as much as some of you have been struggling to keep a passing grade. So other than that, good luck, and like I said, be ready for that test tomorrow.